Okay, folks, example number 1 here. It says for triangle JKL, find the sine and cosine of angle L. All right, so I'm looking at this angle. Okay, and we'll remember from the notes that the sine is equal to the opposite over the hypotenuse, and that the cosine is equal to the adjacent over the hypotenuse, even though I had it written wrong on your notes, and you're going to make that correction for me anyway. Okay. Now, for angle L, the opposite side, right, is the side that doesn't form the angle. So the opposite side of L is 8. And the hypotenuse is always the longest side, and it's the side opposite the right angle. So that's going to give us 17. So the sine of angle L is 8 over 17. We can change that to a decimal, guys, just using our old trusty calculators. Remember, the top number always goes in first, so 8 divided by 17, and that's going to give us 0.4706. And guys, I'm going to round it to 4 places because traditionally in the old textbooks back before calculators, they would have tables for angles. So you'd look up the sine of whatever angle, and it would give you its value, and they always rounded it to 4 places. So it's traditional that we give trig functions to 4 places. All right, so that's the sine. All right, and then the cosine of L is going to be the adjacent. Okay, now remember, adjacent is the side that helps form the angle but is not the hypotenuse. Okay, so the adjacent to L is going to be 15 over the hypotenuse, which is 17. Okay, and if I take my calculator and change that to a decimal, I'm going to get 15 divided by 17, and that's going to give me 0.8824. Okay, so that's approximately the cosine of angle L. All right, and guys, I want to show you something since we have just a bit of time here. Okay, each of these angles have measures. Okay, that's the measure of angle L and measure of angle J. K, we know the measure of angle K is equal to 90 degrees. But we can actually use these values and our calculators to find out what the degree measure is of these other angles. Okay, so I want you to do this. If you have your trusty calculator near you, okay, I want you to do this. You can see above the sine, cosine, and tangent buttons, you're going to see sine to the -1 power, cosine to the -1 power, tan to the -1 power. It's actually not the -1 power. What it's saying is it's the inverse. It's saying, give me the angle for this trig value. All right? So if I know the cosine of L is let's see, there we go, is 0.4706, I can type in second sine 0.4706 and hit enter, and it's going to give me that angle L is approximately 28.07 degrees. Okay? But now wait a minute. If I do the cosine inverse, right, these things look like this. Sine inverse, right, gives me an angle. Cosine inverse should give me the same angle, right, if I plug in that value. So if I take the cosine of L, if I do second cosine and I type in 0.8824, I should get something close to 28.07 when I hit enter. And I do. I get 28.07 when I round it. Okay? So we can use these values to actually find the angle measure. We don't need to use a protractor to find the angle measure. Okay? Now, what I also will notice is that if I know what 2 of the angles are, this isn't measure of angle J, it's measure of angle L again. If I know what these 2 angles are, then I can add them together and subtract from 180 to find out what the third angle is. All right? Okay, my time's running out here. But you guys see I can use those trig functions to find out the measures of angles. All right? Good job.